Could everything we thought we knew about the universe's first stars be wrong? Imagine the heart of cosmic darkness where no light has yet been born and the very first stars are beginning to form. But not in the way we always imagined. According to new findings, the universe's first stars may have been far smaller than previously believed. And that very smallness might explain why we've never found any trace of them. These stars were born in a violent, chaotic environment, inside massive, turbulent clouds of gas moving at speeds 5 times the speed of sound in Earth's atmosphere. Simulations from the new study revealed that the gas clustered into lumps and ridges, signs of imminent star birth. Eventually, one of these gas clouds stabilized and gave rise to a star with a mass only 8 times that of our Sun, far smaller than the 100 solar mass giant scientists once envisioned populating the early universe. The findings suggest that the first superstars in history may have formed in star networks, not in the majestic isolation astronomers had long assumed. Kujang Chen, lead researcher at the Institute of Astronomy and Astrophysics at Academia Sinica in Taiwan, explained in an email to Live Science. The presence of supersonic turbulence causes the cloud to fragment into smaller clumps, which leads to the formation of several lower mass stars instead of a few massive ones. These early stars played a crucial role in shaping the first galaxies that eventually evolved into systems like our own Milky Way. To reach this new understanding, researchers used the advanced simulation code Gizmo, a tool designed to study astronomical phenomena ranging from black holes to magnetic fields. They also utilized the illustrious TNG project, which has previously proven effective in recreating galaxy formation with high accuracy. The goal of the study was to explore the conditions of the cosmos a few 100 million years after the Big Bang, around 13.8 billion years ago. Given the vast scale of the universe, the simulations focused on a specific region, a dense structure known as a dark matter mini-halo, with a mass roughly 10 million times that of our Sun. Dark matter makes up most of the universe's matter, but it doesn't interact with light and can't be seen through telescopes. However, its presence can be inferred by its gravitational effects on other objects. Researchers examined how gas particles moved within relatively small spatial regions inside this halo, each about 3 light-years wide. The simulation showed that the dark matter mini-halo pulled in gas with its gravity, triggering both supersonic turbulence and the clumping of gas clouds. In other words, turbulence was an inseparable part of the process of forming the universe's first stars. This intense birth environment had another side effect: the number of massive early stars was likely far lower than previously thought. Earlier studies suggested that stars with masses over 100 times that of the Sun could have existed. These ancient stars would have eventually exploded as supernovae, leaving behind detectable chemical traces that newer stars would absorb during their formation. However, newer stars show no such chemical fingerprints from these massive ancestors, suggesting that the first generation of giant stars may have been extremely rare. Chen's team isn't done yet. They're now using dark matter halos to study how supersonic turbulence operated more broadly in the early universe, especially during the era over 13 billion years ago known as the Cosmic Dawn, when the first stars emerged. According to Chen, the next round of simulations may include magnetic fields. In today's galaxies, we see that supersonic turbulence amplifies magnetic fields and influences star formation. It's possible that magnetism played just as vital a role in shaping stars in the early cosmos. So maybe the first lights of the universe weren't the brilliant, solitary giants we imagined. Instead, small clusters of stars quietly lit up the darkness and paved the way for the galaxies we know today. If the first stars were so small and hidden, what other secrets might still be lurking in the shadows of the cosmos? Could traces of these ancient lights still be waiting to be discovered somewhere in the sky?